My Year 10 students couldn't believe that they had to do quadratic equations to solve this geometry question. Where on earth did they come from? And how on earth are we going to find the radius of the smaller circle when all we know is that we've got two circles inside of a 6x4 rectangle? That doesn't seem like enough information to find that. When we start a challenging question like this one, consider the things that you do know. What can we find out that might link to the radius of the circle? We know that the larger circle touches 3 sides of the rectangle, and we know that the smaller circle touches 2 sides. And because we know the height of the rectangle is 4, that's going to have to be the same as the diameter of the larger circle. So the radius of the larger circle would be 2. Now, another good general strategy is we join up the center of the circles together and to any points of tangent, or any tangents to those circles. This is working with the diagram, and it often splits it up into shapes that are useful for us to work with. Now, because we know the radius of this larger circle is 2, we can label all of these with a 2, and because we're looking for the radius of the smaller circle, we can label these with an R. Now, if you pause here, that's totally fair, because it takes a moment to notice what we want to try next. But we want to link together these 2's and r's to form an equation. And what we have here, if we just add one extra line across, is a right-angled triangle. And if we can express all of the sides of that right-angled triangle in terms of r and numbers, we can use Pythagoras' theorem to link all those sides together and then solve it for r. Now you probably start to see where that quadratic equation is going to come from. So this length here, well, that's going to be the radius of the circle minus this length. You can see the smaller rectangle of height r. So this part's going to be 2 minus r. And the length of this smaller rectangle, that's going to be 6 minus 2 minus r. So this length here is going to be 4 minus r. And now we've expressed all of the sides of our right-angled triangle, so we can use Pythagoras' theorem to form our equation. So we've got 2 minus r squared plus 4 minus r squared is equal to 2 plus r squared. So now we can dive in, expand all these perfect squares, and try and solve this. So we don't want to forget our middle terms as we expand these perfect squares. So we've got 4 minus 4r plus r squared plus 16 minus 8r plus r squared is equal to 4 plus 4r plus r squared. Now we just need to collect our like terms. So we can cancel off an r squared from both sides. We can cancel off that 4 from both sides. And we're just left with r squared minus 8r minus 4r minus this 4r as well. So that will give us minus 16r. And then we've just got this plus 16 here, and that is equal to 0. So in order to solve this and find what r is, we just need to solve this equation. So how are we going to factorize this equation? We consider the factors of 16. We've got 16 and 1, 8 and 2, 4 and 4. None of those are going to add to minus 16. So we're going to have to use either the quadratic formula or we're going to have to complete the square. So we've got r minus 8 squared minus 64 plus 16 is equal to 0. So we've got r minus 8 squared is equal to 48. We can now square root both sides. So we've got plus or minus, and the square root of 48, 16 times 3 will be 4 root 3 is r minus 8. And we don't want to be quick to get rid of the negative solution, because could the radius be 8 plus 4 root 3? That would make the radius of the small circle larger than the whole rectangle. Wouldn't make sense. So actually, the solution that we're looking for here is r, the radius, is equal to 8 minus 4 root 3. And if you think about what root 3 is, it means it was between 1 and 2. So that means that this will be positive, because 4 times something less than 2 but more than 1 is going to be between 4 and 8, so say roughly 6. So that would make the radius here probably slightly less than 2, which fits the equation and the question and looks about right. So we have our final answer, proven mathematically. I hope you liked that. Let me know in the comments if you did.